Okay, question 14's a tough one if you go into it proper deep. I've got to be really careful with my language, so as best you can, try and keep track of the terms that I'm using. So we start with a curve, y equals x squared minus x minus 2 to the power 4, and this is an x to the 10 curve. Nobody has the ability to be able to imagine the shape of that curve for A-level maths. So we are told that it has a maxima, and that's going to be where the gradient of this line, dy by dx, equals 0. So the gradient equals 0 when x equals a, and correspondingly when x equals a, y equals b, and we've got to find b. So we are going to have to differentiate this with respect to x. We'll use the chain rule for that to get started. Let t equal x squared minus x minus 2, such that y equals t to the 4. Differentiate y with respect to t to get 4t to the 3. Differentiate t with respect to x to get 2x minus 1. And then combine these two together to get dy by dx, which would be, I'll go 4t to the 3, 2x minus 1. Resubstitute back in what t was, and t equals x squared minus x minus 2. So we have dy by dx equals 4 x squared minus x minus 2 cubed, 2x minus 1, and we want the gradient to be equal to 0. Okay, so we have a solution popping out right here when x equals a half, but I want to go in just a little bit deeper, so we can factorize this expression here as well, if you don't mind me doing it in the old school fashion, splitting the middle term of the brackets here, x squared minus 2x plus x minus 2 to the 3, 2x minus 1 equals 0. Put the 4 back. And then pulling out a common factor here to leave behind x minus 2, and that will leave behind also x plus 1. So we'll have 4x minus 2 cubed x plus 1 cubed 2x minus 1 equals 0. Okay, so the 4 doesn't matter. We can divide both sides by 4 to get rid of the 4, but clearly we have 3 moments, 3 x values which produce a gradient of 0, and that's going to be when x equals this one, which will be minus 1, this one, which is a half, or this one, which is 2. So how can we tell which of these is going to be, as we say, a maxima of some kind? So we're going to, you can inspect them by inputting, say for example, 2.01 and 1.99 and see what happens to the curve either side of these x values in order to find out which one looks like a maxima in that circumstance. But because the topic is about sort of differentiating twice and points of inflection, we can see if any of these are points of inflection, because if they are, they can't be a maxima or minima. So I'm going to get a new piece of paper, and we're going to have a look at the second derivative of this expression at the top here, derive it again. So if I slide this fresh piece of paper up to here and pick up the story, we've differentiated t with regards to x once. We can do that again, d2 t by x squared would just be equal to 2. And we can do this one again, so d2y by dt squared equals 12t to the 2. And then we can pull these two together to get d2y by dx squared, which would be 2 times 12, which is 24t squared. Substitute back in our original expression for t, which was x squared minus x minus 2, to get d2y by dx squared equals 24. Open brackets, x squared minus x minus 2, close brackets, squared. So what does the second derivative give us when we put in x equals -1, a half, and 2? So we'll do that in turns. And I'll write that as when x equals -1, when x equals a half, and when x equals 2, comma, 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 d2y by dx squared equals d2y by dx squared equals d2y by dx squared equals. In this case, when we put in x equals -1, so we've got -1 squared is 1, 1 minus -1 is 2, 2 minus 2 is 0, squared 0, 24 times 24 is 0. So this one produces 0. Going down to 2, we've got 2 squared is 4, minus 2 minus 2 is 0, 0 squared, 0 times 24 is 0. This one is also 0. And then when you do this one, you've got a half squared minus a half minus 2, all of that squared times by 24, and you end up with the slightly uncomfortable looking 243 over 2. So that means this one can't be, this value of x can't be a maxima or minima because it's a point of inflection. And this one can't be a maxima or minima because it's a point of inflection. So the x value that we're looking for is this one. And then the final punchline is going to be the y value when x equals a half. So we have to go right the way back to our original expression for y, which is now going to be substituted in with a half. So let's pull this way around now and go open brackets, a half. Let's try this again. Let's put 0.5 squared minus 0.5 minus 2 to the power 4 equals, and then that would be the y value, or b, to your answer to this question. This question's a good question. It's deep. It's got a lot of depth to it.